Hello, Algebra 1. Well, today we're going to look at lesson 1.4, solving equations and inequalities with variables on both sides. Something I do want to mention is normally when you have variables on both sides of an equation or an inequality, you might have special cases. Today we're not going to look at the special cases. These are going to be a little more straightforward. Special cases would mean no solution or infinitely many solutions. We'll get into those later. So you got your objectives there, solving them, and then we're also going to do some pretty interesting word problems on the back. And I'm kind of tempted to start there just because I find them interesting, and it may kind of give you a reason for doing equations with variables on both sides. So yeah, let's start on the back if you don't mind. Read through there. A boat leaves New Orleans and travels upstream on the Mississippi River for 4 hours. Man, if you're in a boat traveling upstream, that's hard work. The return trip takes only 2.8 hours because the boat travels 3 miles per hour faster downstream because the current's pushing you downstream. It's helping you out. And then the question is, how far does the boat travel upstream? So there's a few tricky things about this. First things first, we're not actually going to find how far does the boat travel upstream. That's not going to be, F is not going to be, or D for distance, that's not going to be our variable. We're actually going to solve first for the speed of the boat going upstream. That's going to help us to figure out the actual distance. So we are going to be using a formula, DIRT, distance equals rate times time. We're going to be using that. But also we're going to have to realize that there's an equation here that we can look at. And the reason I say that is our equation, one side of our equation is going to be the distance traveled upstream. The other side of our equation is going to be the distance traveled downstream. They're going to have to be equal because the boat goes upstream, turns around, and comes back to the same point. So those are going to have to be equal. So now what I'm going to do is I'm going to realize, okay, they're telling us 4 hours upstream, but they don't tell us how fast we're going upstream. So we can't quite use DIRT yet. But it says the return trip takes 2.8 hours. But here's the key. It says on the return trip, it's 3 miles per hour faster. So what we don't know is we don't know X, we'll say. X will be the speed or rate upstream. We don't know it. So we're going to write an equation here where we've got distance upstream. So distance is equal to rate, we don't know it, times time, took 4 hours. Distance upstream is going to be equal to distance downstream. Downstream, we're not going 3 miles per hour. We're going the speed upstream plus 3 miles per hour. And that needs to be multiplied times the time of 2.8 hours. So that's the situation we're looking at. And then once we've got this equation, you can see how we've got variables on both sides. Let's clean this up a little bit. X times 4, we typically call just 4x. On this side, let's clean this up by distributing the 2.8. Simplify it. And 3 times 2.8, I think that's 5.4, if I remember correctly. And I would be wrong. That's way off because 2 times 3 is 6 already. It's 8.4. There we go. And now when you're solving equations with variables on both sides, you're going to want to get those variables together so that you can solve for a single x. And so typically what people do is they avoid having 0 on one side because that tends to extend the problem out. They also sometimes avoid negatives if possible. Since I'm going to avoid negatives and I'm going to avoid 0, I'm going to subtract the 2.8x to the other side. And then I'll get 1.2x is equal to 8.4. And then class, you just solve this like a normal equation, divide by 1.2 on both sides. And it turns out that x is 7. And if you recall, x was the speed upstream. So it was 7 miles per hour upstream. So to find the distance upstream, we're going to multiply that 7 miles per hour times 4. Distance equals rate of 7 miles per hour times time of 4 hours. And the distance upstream and downstream is 28 miles. So we did a word problem and we were able to solve an equation with variables on both sides. This next one I kind of enjoy, and it's not as difficult as it may seem. You need a mean score of at least 90 points to advance to the next round of the touchscreen trivia game. We actually have one of these in our basement. It's kind of fun. It's way old. It's from the 90s. So notice we've got some information here. Mean. Another name for mean is average. That might be a little more helpful for you. Also, it says we've got at least 90 points, so it's sounding like an inequality. And it says what scores in the 5th game will allow you to advance. See, we've got some scores already. So they're saying, well, what score would you need for the 5th game in order to get at least an average of at least 90 points? So I think I'm kind of ready to set this up. If you recall, to find the average of things, you add how many there are and then divide by, or you add all you add the values and then you divide by how many there are. That sounds a little better. So that's what I'm going to set up here. We're going to do 95 plus 91 plus 77 plus 89. But we've got one more score that's going to be part of our average. We don't know what it is. And then we divide that by how many there are. 1, 2, 3, 4, 5. We know that this average needs to be at least 90, which is greater than or equal to 90. And so it turns out we don't have variables on both sides on this one. It's just a more complicated sort of word problem. Combine like terms here, you'll get 352 plus x divided by 5 is greater than or equal to 90. You can't subtract the 352 until you get rid of that 5, so let's multiply by 5 first. Oops, 450. Subtract that 352 over, and you get x is greater than or equal to 98. So on that last game, you've got to get at least, you got to get at least 98 points to move on. So anyway, there you go. So x was our game 5 score. If you're labeling those, your game 5 score needs to be at least 98. Sweet. All right, well, let's move on to just the straightforward algebra problems. I guess I'm tired today. Well, on part A, notice variables on both sides. We want to avoid getting 0 because it just kind of expands things. So I'm going to add the 4x over to get those together. And then divide by a -5. And you'll get -2. It's an equation. I don't bother graphing most equations. I think I may graph the next one just for kicks, but most equations I don't bother graphing because the graph doesn't really give us any additional understanding. Let's move on to the next one. We want to get these x's together. To avoid negatives, I'm going to add a 2x. Now, one thing I want to clue you in on, if I'm moving the x's over here, and my goal is to solve for x, I'm going to end up having to move this 12 over here. So I'm going to go ahead and do it in the same step. And we get -17 is equal to 6x. And divide by 6, and it doesn't come out nice. Most of you have a fraction button on your calculator. If it doesn't come out nice when you divide it, go back to your fraction, but then punch it into a calculator with the fraction button and see if it reduces. So I'm going to do 17 fraction 6. And so it turns out it didn't reduce, but they did rewrite it as a mixed number. But notice it's still 6 as a denominator there, so it didn't reduce. So you could have your answer as negative 17 over 6, or you could have negative 2 and 5/6. We don't want to get decimal answers. You don't want to do 17 divided by 6, and you don't want to write that decimal down because you're going to have to round it. We want exact answers if at all possible. So either of these would be fine. Now I am going to go ahead and graph this on a number line because I want you to think about when you have fractions. What integers is negative 2 and 5/6 in between? So I'm going to write negative 2 and 5/6 in the middle there. What would be to the right of it? Yeah, you'd be going down, or sorry, I should say going up, but it's going to be a less negative, so it's going to be a negative 2, and then to the left would be a negative 3, and we just put a dot right there where that's at. All right, next up, get those x's together. That way I'll avoid the negatives. Since we move the x's over here, I'll move the 5 over here. Just like so. On part D, let's distribute everything to get these x's unlocked. Oh, I'm not going to do that, and that's what I get for using pen. I'm going to go ahead and distribute that rather than rewriting it. There, like it never happened. I'm going to distribute that. And when I do 1/4 times 32, or 32 divided by 4, I get 8x, and then 56 divided by 4 is 14. I'm going to move this 8x over to keep things positive. So if I move the 8x over, if I'm moving the x's over here, I'm going to need to move that 36 to the other side. Oh my goodness, 36. I'm making all sorts of mistakes, aren't I? Oh my. Oh my indeed, that's just a 12. Whew. The good thing is I'm catching the mistakes, so that's a positive. We're gonna add a 12 to the other side. X is equal to 26. Okay, whew, let's watch that. Watch me today. And then the 1/2, let's distribute it, see what's left over. Now, I'm going to do what I normally wouldn't do. I'm going to subtract the 3h. And I'm going to end up with a negative. And I just want to do this to show you it still works. I'm moving the h's over here, so I'm going to subtract the 1 there. This will still work. It's just that now I've got to contend with a negative. So now I'm going to have to divide by a -8, and since I'm dividing both sides by a negative, the sign's going to flip. And I'm just going to get a nice fraction answer here. I already see that that's not going to reduce. You can do 3, I'll show you, 3 fraction 8 to see if it reduces. It does not. It does not reduce. So 3/8 is our answer. And then we got to graph it. 3/8 is between 1 and 0. Dot and less than. And there you have it. Okay, so our last one here. Before we get the x's together, let's go ahead and simplify this side. Negative 3x plus 8x, that's 5x. And from there, now get the x's together. I want to go ahead and do it what I think is the best way. Let's subtract the 3x over since we're moving the x's over there. Move that 6 over here. And then divide by 2 and graph it. All right. Hey, thanks for hanging in there with me. Sorry about the mistakes. Have a great day.